So today's question is basically problem of the day is find the punishment number of an integer. It's a very good question. What we have to basically do? So we have to find a punishment number. Okay. So what is punishment number according this question? We have basically, let me explain. We have given a positive integer that is 10. Okay, that is basically n, and in this input there is 10. Okay, we have to find the punishment number. Okay, is of this n, that is in this example 10. Okay, we have to return the punishment number. And what the condition for punishment number of n is defined as that if for every I, that is from 1 to n, the number that is from 1 to n, the number should present between the 1 to n. So what we have to do is that I into I can be partitioned into contiguous substrings such that the sum of the integer value of this substring equals I. So here's the explanation of the question. That is, we have given an n, that is 10. Okay, I have used the example 10, and we have to choose n between 1 to n, the numbers that when we square the numbers and when we add the partition of those number, then simply it gives the value that is I of the number. Okay, that we have chosen in between the 1 to n. Okay, so first number is 1 that we have chosen. If we square 1, because 1 square is 1, so this gives 1 as the number chosen is also 1. Okay, the second number is 9. If we square the 9, okay, it will give simply 81. If we add the 8 plus 1, then simply it will give 9. Then for third, it is 10. If we square the 10, and if we partition the 100 into 10 comma 0, then simply it will give 10. It can be partitioned in any form. Okay, in any form, it doesn't matter, 1 comma 0 or 0 comma 1. It can simply be partitioned in single digits or two digit, in any form. Basically, it can form any possibility. Okay, so this is how, and we have to simply add these squares, and we have to return the total sum of these. So this is our punishment number of this question. So here's the basically explanation of the question. I've basically explained the question. So here's the explanation of approach, what we will do. Okay, so if we see the question, then we have to find the every possibility. Okay, we have to find every possibility of the partition. Okay, if we basically have we have to partition the every string into every possibility, so that it gives the sum equals to the I. Okay, so when we encounter the when we have to use when we see terms like possibility or every possibility, like then we have to use recursion. Okay, so for finding every possibility in any question, then we have to always use recursion. Okay, so here's also we will use recursion, but where we will use recursion when we get string of the squared basically number. We will first convert the squared number in the string, and then we will find every partition on that basically string, so that we can, and we will then take the sum of the partition, and then we will simply check if the sum equals to the target or not. Then what we have to basically do is, this is the approach I have written here. We will check for every I, and we will simply use recursion. Okay, so for checking partition we will use recursion. Okay, and we don't use brute force like using loops. Okay, so it will simply leads to exponential time complexity. Okay, so that's why we are using recursion. So what we are going to use in recursion for basically, I have told you we will use recursion for string of the square number. Okay, we will convert the square number into the string, and we will check recursively on that string if we'll calculate the partition, and we will simply check if the sum of the partition is equals to the number or not. Okay, so for using recursion, Okay, for using recursion, what would the best base case of? Obviously we have to calculate the base cases, okay, because without the base cases recursion is not possible. Okay, it will simply give infinite loop. Okay, so we have to calculate the base case of the this approach. So if we take the example that we have taken the n, let's say n is 10, and we will simply check for one uh, squared number. Okay, that is if it I is equals to 9, the square of the 9 is 81 simply, and we will change it to string, that is 81 in the string. Okay, this partition function will I check recursively of the every substring part. Okay, every partition, if the sum of the partition is equals to the sum target or not, basically. Okay, equals to the target or not. So what will the base case? So if we check if the iteration, basically if the starting index of this function is at the last. Okay, okay, the string is completed. Okay, if we have completed the string checking, so then simply we can return. Okay, we don't have to again further use because the string is completed. Okay, so the first base case simply would be if the start index equals to the this square string size. Okay, size of the square string, then simply we can return what we would return. We will return the sum equals to target. This means that we will check if at this time sum is equals to the target or not. If the start index, basically if the start index is at the last position, we will simply check if the sum is equals to the target or not. Okay, if the string is handed, then we'll simply check if this sum is equals to the target, then it will simply return true, and the loop will the function will exit and it will return true in our main function. If this not, then simply it will return false. The second, basically, base case would be what could be this next thing. Okay, okay, if the sum is greater than the target, sum could be greater than target, and this we didn't want, then we simply return false. Okay, at that time. Okay, so the next, these are the two base cases that would be possible for our question. So for this recursion, okay, so what we will do, how the recursion works, we'll see now. Okay, so let's take this example as 81. Okay, in this string 81, simply we will check for every iteration of this 81. Like if we see in this function, what we'll do is we will simply, after these base cases, we would loop through this string. Okay, what we will do is we will loop through this. Okay, that, let's check an variable I, and it will simply substring the this string. It will, what it will do is it will break this string in, it will break the string for every integer. That, like, for first, it in loop, for first substring, it will simply return, basically what it will return is let me write. It will simply give 8 as a value. Okay, so we will change it into number, and the sum would be, okay, sum would be 8. Okay, the sum will become 8, and then again we will simply check for other one, but we have to return this whole thing in the partition function again. Because we have to check recursively. Okay, so first iteration, that start index would be 0 for first, and the square string would be 81. Okay, and the sum would be 0 for first, and the target would be 2. Okay, so no, sorry, target would be 9. Okay, so the target is 9. So what we will do is simply we will check if the this sum is 9 or not. So for first iter for if we will take the loop, we will use the loop after this base cases, and for first value we will iterate through this string for every partition. For first partition it will give simply 8 and the sum would become 8, and then again we will call partition function. Okay, partition function. For next, basically start index would be, what would be the start index? It will simply will equals to plus 1. Okay, for next, and the sum will be this the new sum. Okay, and the we will simply give the square string and the everything would be same. Okay, so after this we will check for 1, and the next would be start from 1. Okay, in this loop then it will start from 1 and then it will simply update the sum as 9. If I write here, then the next for next iteration sum would be 9. Okay, it will check for 1, and then after this, then again we will call for next start index. Okay, this function, and then it will simply, we will give start index as here the start index will be 1. Okay, and the simply we will check for next, like if we see next, if we will give is start index now is 1, then simply we will provide 2. So it will simply give, and this sum will be equals to 9. It will simply check again the base cases. Okay, for this function. Okay, for this function, this. Okay, also it will check the base case, and it will simply give it will not the base cases are basically start index equals to equal to the last index. It is not, so simply this will iterate through the loop. So it will check for 1, and then again we will send the partition function. It will simply check, and this time the base cases would be there. Like if we see partition, we are on the second index. Okay, and the square string index is basically total, the size of this string is 81, this is 2. So it will simply check on this base case square index equal to the square string dot size. It will simply will be valid. Okay, so it will then check return sum equals to the, it will check if the sum equals to the target or not. Then the sum is 9 and the target is 9, so it will simply return true. This function will return true. Okay, so this next time this function will return true. I have basically make a chart so that you can understand more easily in this. Like here I have written again. Okay, this is the basically start index. So I have provided the basic pseudocode of this, like these are the base cases and this is the for loop. We will partition the string in parts and convert them in integer and add them in sum. Okay, so what how will we do it? Okay, so this is basically the approach. Okay, we will check recursively for function 1. Like if we see, like if function 1, the target, basically target not target, the start index is 0 and the sum is 0, it will simply check for next, and the function next it will simply check recursively for next value of the next partition. That is simply it will give provide 1 as a start index for next partition, and the sum will be 8. Okay, so for this iteration sum was 8 and x was 1. For next sum would be 9 and x would be 2. And so at this case sum would be equals to the target, and the number and the start index would be at the last of the. Okay, simply it will follows the base case and simply it will return true, and this will return. And in recursive approach, in the recursion, the function just return the answer to previous function that from where it was called. So it will return to this function, it will simply give return true, and this function will return to its previous function, it will simply return true, because this function is completed. Okay, so this will complete this function and this, so then this function, so this function will return true for this 81, and it will simply, we will add the result in this result plus squares. Okay, we can simply memorize it. What can we do it? So which see, basically this approach is fine, and will take 2 to the power something time complexity. Okay, In this approach, many substrings or many partitions are repeated. Okay, in recursive approaches, basically many times the partition or the many basically function repeats itself again and again, okay, for various values. Okay, so what we will do is we can simply memorize it by using a dp array. Okay, we will use a dp array and simply the we will use a dp array and we will simply initiate the dp array with -1. Okay, and then simply we will store the values that we have basically we have iterated. Okay, like we have on the 8 or we have 1, we will simply store these values in this dp array. If we come again on these values or this partition string, okay, then we will simply not give basically not check for function. We will simply check our dp array. If the value is there, we will simply return the value from this dp array. Okay, not using more many times this function calling function. Okay, so that's why we are using dp array. So I will provide you the memoized version of this code. Okay, so you got this recursive. If you got this recursive approach, okay, if you got this recursive approach, then just the 2-3 lines we have to add to memorize it. Just we have to add the dp array. Okay, and here okay, and here we'll simply check if dp if dp okay, if dp array is not equals to -1. Okay, basically we will provide -1 at every index of the dp array. If not equals to, then simply return the dp array. Okay, simply return the dp array. Okay, we don't have to go to this function. If we have the value at this we have the value at in dp array, then we have to just simply return the value. So this is basically the approach. We will simply use dp array to memorize it. So I will provide you the code and I will explain you the code in this LeetCode also. So main function is this punishment number. Okay, what is doing, I will explain line by line. Okay, I have taken the variable punishment number that will store the mean answer of them. Okay, for every number that is I equals to 1 to I equals to n. Okay, so for every number we will square the number. Okay, we will change this string, we will change it to basically string. Okay, that number into string, and we are basically making an dp array with the size of this string. Okay, size of this string, and we are basically using a vector in the dp array. Okay, in vector and vector basically we are using a vector, and we are using this as a -1 for every index. Okay, just main focus on the concept. Okay, if the partition is a function that is recursively check if this gives true, then simply we will add the square number in this punishment number and simply return this. So we will check for the partitions. Okay, main is this function that is checking for every partition. These are the best cases. If the start index, okay, start index is equals to the last index, or it is on the last index, it will simply check if the sum equals to the target. It will simply return true, or if not, then it will simply false. Okay, if the sum is greater than the target, it will simply return false. This I was talking about, this will memorize the answer. Okay, this will basically check if the number if we have checked the string previous time or not. Okay, it will simply return the answer from dp array. No, don't have to give enter into this loop. I've taken this variable that is we have initialized as false. What we are doing in this loop is that at every start index we will simply iterate through, and we will substring uh, the string that is basically provide a square string. Okay, we will substring the string from start index to the previous one. If I just check for first 81, okay, like if I check this is the 81. Okay, if I check for 81, what will the start index is 0. Okay, first we have provided the start index and sum as 0 because it is 0. So what is this 8? Okay, 8 as on 0. Okay, it is on 0. So simply the I is 0. Okay, it will, what will the substring answer? The start index is 0, and I minus I is also 0, because I is equals to start index. 0 minus 0 plus 1. So simply it will substring this 8 from this value. Okay, and it would add, it will take an variable add string, and it will simply change this string 8 into number. Okay, and we will simply check partition found. Okay, this we will simply iterate again, and basically recursively call again this function for next iteration. Okay, I plus 1, we have given the next start index as I plus 1. Okay, and some will be add string, this we will add this in again, and the square string. Okay, we will provide, and the target and the dp. Okay, simply dp array will always there, and here we have also provided target. So simply it will check, and if we are checking if partition found is basically we have initialized here is true, or this is or sign, or this is true. Basically if both are true, then it will simply return true, or any one will true, it will simply give true. And if the partition found is true, then simply it will return true. And we have to return this dp array. If the dp array we have the number in the dp array, then we'll simply return true. Okay, so this is the code I have tried to explain. Okay, let me tell how